all. So today's question is, what is a confusion matrix in machine learning? So we know that whenever we apply any model to our data set, any algorithm to our data set, we need to find out whether that algorithm is performing good or not. Means we have to find out the performance of any model. So for that, we have various parameters, various evaluation measures to find out the performance, whether the model or the algorithm is performing good or not. So we have different evaluation performance parameters for classification problems and for regression problems. For classification and regression, we have different evaluation parameters. We have different evaluation parameters. Okay, so one such matrices for classification problem is confusion matrix. So confusion matrix is a evaluation matrix for classification problem. So now let's understand what is the confusion matrix. So confusion matrix is a for first we can say that we are starting for binary classification. So for binary classification means what? Binary classification has output or target variable has two classes, either 0 and 1, yes or no, true or false, like that. And what is multi-class classification? The classification or the categorical feature that has more than two classes. Okay, so let's understand confusion matrix for binary classification. So for binary classification, confusion matrix is a 2 cross 2 matrix. For similarly, for 3 classes, it is 3 cross 3 matrix. For 4 classes, it is 4 cross 4 matrix, like that. So we'll start with 2 cross 2 matrix, that is for binary classification. So confusion matrix is a 2 cross 2 matrix. Let's draw the confusion matrix. So here it is divided into 2 cross 2. So here we have actual ones. We'll understand this. What is actual one? Actual 0. We have predicted one, and predicted 0. Okay. So for example, we have this as our data set. In that, input features are F1 and F2, and our output, that is target variable Y, that has this as values, and our model predicted this as values. Means for 0, our model has predicted 0. Here in second row, model predicted 0 for 0, 1 for 1, 1 for 1. But here see that the actual output was 0, but our model has predicted 1. Here, see that our actual output was 1, but our model has predicted 0. So, we'll find the performance of our model with the help of confusion matrix. Okay. So, this is our confusion matrix. So, it has, in this dimension, it has actual values, actual ones. Here, it has predicted values. So, this portion is known as TP. This portion is known as Fn. This is known as Fp, and this is known as Tn. So let's understand the terminologies. What is TP? TP is known as true positive. This is when the actual value is 1, when the actual value is 1, and model also predicted 1. model predicted 1. So understand here, actual is also 1 and our model also predicted 1. So this is true positive. So what is true negative? It is true negative. This is when the actual value or the actual output is 0 and model also predicted 0. Model predicted 0. So see here, actual it is 0 and model also predicted 0. Right? Next is FP. This is known as false positive. False positive. This is when the actual output is 0. When the actual output is 0. Actual output is 0 and model predicted 1. But our model predicted 1. See here, your actual output is 0, but your model predicted 1. Okay, so last is Fn, that is false negative. This is when the actual output is 1, when the actual output is 1, but model predicted 0. So see here, when your actual output is 1, but model predicted 0. So this is Fn, that is false negative. So this is about the terminologies used in confusion matrix. So from here, we can see that this value, this TP and TN, this TP and TN says that these are, TP and TN says that these are correctly predicted. Correctly predicted. While FP and Fn are the values that are predicted incorrectly. Predicted incorrectly. Right? So let's understand this with this example. So we'll make the confusion matrix for this data set. So let's make here. So we'll calculate how many TP are there, how many Fn are there, how many FP are there, and how many TN are there. So TP means true positive when the actual value is 1 and model also predicted 1. So let's find out how many are there. This is 1. This is 1 for 1. And this is 1 for 1. So TP is equals to 3. So we'll write here 3. In place of TP, we'll write 3 here. Then next is TN. So when the actual output is 0 and model also predicted 0 means correctly predicted. So this is 0 for 0, 0 for 0, 2, and this 3. So we have 3 as true negative means for 0, model also predicted 0. Then comes to FP. FP is when the actual output is 0, but your model predicted 1. So actual output is 0, this one, and your model predicted 1, this one. So we have 2 FPs. Similarly, we have 2 Fn. So we can see that these things out of 10, our model predicted 6 values correctly and 4 values incorrectly. So this is confusion matrix, which tells us that how many things, how many values our model predicted correctly and how many are wrongly predicted by our model. So thus, this is used for classification problem to evaluate the performance of our model. And this confusion matrix is useful to find out the precision, accuracy, F1 score, and ROC AUC curve for the model. That are the different performance matrices for our classification problem. These will cover in our next video. Thank you.